In this video, we're going to determine the type of function from a table of values and then be able to write the equation of that function. Now, there are three main functions that we're going to be looking at today. We got linear, we got quadratic, and we got exponential. So if you look at the table on the right, linear are straight lines. They are in the form of y equals mx plus b. The y changes by a constant amount per unit interval. So that means there is a slope involved. And how do you determine that from a table of values? You find the first difference. And if the first difference, if all the first differences are equal, then that would be our slope. The difference is just the answer to our subtraction problem. So when we're trying to find the change in our y values, we're going to take a y2 minus our y1. If it's a quadratic function, it's going to be in the form of y equals ax squared plus bx plus c. It's going to be parabola shaped, which means it's got bends in it. There's an axis of symmetry through it. The y increases to a maximum or it decreases to a minimum, and then it begins to decrease or increase respectively. So it changes directions. The second differences are equal. So what do they mean by second differences? Well, if you do the first difference to see if they're equal and they're not, the second difference is just the answer to the subtraction of your first differences. And then half of the second difference is going to be your a. And then if you know what your y-intercept is, you can use the a, so half of your second difference, and your y-intercept plus a coordinate from the table to find your b. And we'll go through an example of that once we get to our examples. And then the other kind is exponential, which is in the form of y equals a times b to the x power. B cannot be negative and it can't be 0 because it has to be greater than 0. Or if the b is 0, then you wouldn't have an exponential involved. So when y grows or decays by a constant rate per unit interval, and to find out if it's got an exponential, it's going to have a common ratio. And to find the common ratio, you're going to take one y value divided by the previous y value. And that common ratio is going to be your base of the function. So now, example 1. We want to check our x's. Our x's are increasing by 1 every time. And our y's are increasing by 3's every time. Now, if I were going to do the first difference, I would just take 7 minus 4 is 3, 10 minus 7 is 3, 13 minus 10 is 3, 16 minus 13 is 3, 19 minus 16 is 3, and 22 minus 19 is 3. So the first differences are equal to each other. So my slope is going to be 3. So now I'm going to pick a point. I'm going to choose this point right here, 0, 4. And the reason why I'm going to choose that is because that gives me my y-intercept, which is my b, in y equals mx plus b. So we know this is linear. And our equation is going to be y equals our slope, a slope of 3, times our x, and our y-intercept is 4. So I would have 3x plus 4. And I can prove that's correct by plugging the x's from my table into the equation, and it should match up with the y value that I'm given. So if I put a 0 in for x, 3 times 0 is 0, 0 plus 4 is 4, and I have a coordinate of 0, 4. If x is 1, 3 times 1 is 3, plus 4 is 7, I have a 1, 7 there. Example 2. Here the x's are increasing by 1s, the y's. If I want to find out the differences here, this is a difference of 2, 4, 6, 8, 10, 12. And then the differences of those would be 2, 2, 2, 2, and 2. Since this has a second difference, we know that this one's going to be quadratic. And then my A is always going to be half of the second difference. So half of 2 is 1. So I know my A is going to be 1. I need an X in here. My B, I don't know my B, so I'm going to put a B here and then a parentheses because we're going to use an X coordinates, plus my y-intercept is 1. So I'm going to put a 1 here. I need to choose a coordinate. I can't use 0, 1 because I already have that in here. It's going to equal 1 and that won't allow us to solve for B. So I'm going to choose another point. I'm going to choose 1, 3. So when y is 3, x is going to be a 1. So I'm going to put a 1 in the parentheses here. So now I can solve this one. 1 times 1 squared is 1. 1 plus b times 1 is just 1 plus b plus 1. So right now I have 3 equaling 2 plus b. To get b by itself, I'm going to subtract 2, and b is going to equal 1. So my equation is going to be y equals, I have x squared plus x plus 1. And if I want to verify that, if I put a 2 in for x, 2 squared is 4, 4 plus 2 is 6, 6 plus 1 is 7. I have a point that's 2, 7. And our last one. Here my x's are increasing by 1, and my b's, this is 3, this one's 6, this one's 12, this one's 24. You can see that the first differences are not the same. And if this was, the second difference was 3 and 6, 6 minus 3 is 3. 12 minus 6 is 6. They're not the same. So I know if I try 6 divided by 3, gives you 2. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. So my common ratio is going to be 2. So I know that this is going to be an exponential. And since my common ratio is 2, I know this is going to be a growth because my y's are increasing rapidly. So my equation has to be in the form of y equals a times b to the x power. We know our b is 2. I need to choose an x coordinate so I can find my a. So I'm going to choose the easiest one here. I'm going to choose 0, 3. So when x is 0 and y is 3, anything raised to the 0 power is going to be 1. So that's going to give me 3 equaling a. So if a is 3, I can write my equation as y equals 3 times 2 raised to the x power. So that is how you can determine the type of function from a table of values, and then also writing the function for each of those tables.